Time for some more kitchen table astronomy at the crow-bombarded kitchen table of Hampshire College astronomer Dr. Salman Hameed, Mr. Universe. We oftentimes talk about the majesty of the universe in many ways and films. I just want to take a brief aside and say, if you have not yet seen Life of Chuck, which is based on a Stephen King story, there is an awful lot about Carl Sagan's cosmic calendar in this. And I won't tell you any more other than if you love Carl Sagan and the cosmic calendar, go see Life of Chuck.
Okay, so, well, thank you for spoiling.
Yeah, spoil it.
Monte.
It's one thing they mention in it. I don't want to say how they mention it or why.
I was planning on seeing it because it is playing at Amherst Cinema.
Where you are a board member.
And so, yeah, it was on my list of things, and I should mention because of Father's Day. So every Father's Day, I get an opportunity to actually watch Carl Sagan's Cosmos. Because
Is that what you do for like a tradition for Father's Day?
yeah,
I
because
love that.
because my kid is forced to watch a show that from 40 years or 45 years ago, and but it's still pretty good. And so yesterday, yesterday we watched that part of it, half of it, because I don't want to torture them because they go like, oh my goodness, this is like, so old, but it's so good. And it was, and so we watched that part of it, and then we watched Interstellar. And it is, I was actually surprised. I had not seen it in a while, but Interstellar is also a perfect Father's Day film. And so anyway.
Next Father's Day. So if you missed it yesterday, you can watch Interstellar and Cosmos next year. I make my kids watch Bill and Ted's Excellent Adventure on my birthday. So I know the drill. But the other thing that's magnificent about the universe is, why do we need to be spending billions of dollars on these space telescopes when the universe itself is a giant telescope? And we are using the universe as a lens to see things close to the beginning of the Big Bang.
Okay, don't say that. I would rephrase that. Don't say we don't need telescopes for that, because otherwise Doge is going to come in and shut down James Webb Space Telescope.
Yeah, please don't.
But you are right. What I want to talk about is a really cool result that has come out. And there was a meeting going on, annual meeting of American Astronomical Society. This time it was in Anchorage, Alaska. I didn't go, but I saw beautiful pictures from astronomers posting it on Facebook and other places. And
The sky looks great there.
yeah, and so next time Alaska, and no, it was beautiful. But one of the results that came up was that there is a mystery about what happened early in the universe. And when I'm talking about early, it's a few 100 million years after the Big Bang.
Which is a long time in human time, but in astronomical time is practically no time.
That's right. And so one of the mysteries is that at some point, a few 100,000 years after the Big Bang, the universe earlier on, before that, was completely opaque because it was so dense that light could not freely travel. It would hit, like photons would hit electrons and protons and things like that. So basically, it would be an opaque place if you were there. And we do not see that light. The first time we see light freely flowing in the universe is a few 100,000 years after the Big Bang, which is called cosmic microwave background radiation. This was the evidence for the Big Bang, because this kind of light, that as the universe expands, it cools a little. And then roughly 400,000 years after the Big Bang, it was cool enough that the electrons could actually combine with protons to form a lot of hydrogen and helium as well, but mostly it's called recombination. It got cooled enough that electrons combined with protons to have hydrogen. Now, this is when the universe in some ways became transparent. And that light, that cosmic microwave background radiation, is everywhere all around us because we are all part of the Big Bang.
The Big Bang didn't happen somewhere far away. The Big Bang happened right where you are right now. The Big Bang happened everywhere.
That's right. And so you have this hydrogen, in some sense, a fog that actually is left out at the time. But over the period of time, over the first billion years, that fog of hydrogen clears out as well, meaning to say that electron in a hydrogen gets knocked out. It's called reionization, or ionization. The process was called ionization, but it used to be the case before, the first few 100,000 years, and then it became again after a billion years. And so the light could even more freely flow, and this fog of hydrogen lifted. You can think about it that way. So there was a big question. What caused this reionization? Meaning to say, what are those stars? Are those black holes? Are those big galaxies? Are those small galaxies? What kicked off those electrons from the hydrogen atoms within about 1 billion years after the Big Bang? And this was a mystery we didn't know, but now one of the results that were announced at the American Astronomical Society, there may be a solution to that. And what I want to focus on, we can talk about the exact solution, but what I think is fascinating is how astronomers figured it out. And I think this is where your earlier comment,
Using the universe as a telescope itself came into play.
right? So because we are looking at a universe 800 million years or 900 million years after the Big Bang, that's when some things happen. We want to study that. And so astronomers used a big cluster of galaxies. Its nickname is Pandora's cluster.
Uh-oh. Don't open that cluster.
And there are a lot of galaxies in there. So this is not a star cluster, but a cluster of galaxies. And it is located about 4 billion light years from us. So it's not as far as we are trying to look at, but it's somewhere in between. But because it has a lot of mass in it, because it's a cluster of galaxies and there are a lot of galaxies in it, it can bend light that is coming from behind it or farther away from it. So this is called gravitational lensing. This is something that was predicted from Einstein's general theory of relativity. But astronomers now use it to look or magnify objects from way back. So basically, if you bend light, you can use it as a lens.
It's how magnifying lenses work here on Earth. It's how your glasses work. But we have taken a cluster of galaxies called Pandora's cluster and turned it into a giant lens to look farther back in the universe than we would have been able to without using the universe as a telescope.
And it's still very hard. You have to really identify, you need a telescope to have this resolution or sort of to peer both faint light that has been magnified from the past, but also to have an accuracy to identify that, this little smudge that you see, that is actually a light coming from a galaxy far, far away and is not part of that cluster. So first of all, this is just incredible. This is really cool to do that. And the telescope that can do that is James Webb Space Telescope.
So we do need a real telescope to do it too.
Before that, Hubble Space Telescope did that. But James Webb Space Telescope is actually one of its key goals was to do this type of science. And it has done that. So what astronomers have found, they identified about 83 objects that are way farther back, but they are being magnified. And out of those, they closely studied 20 of those galaxies. And within those 20 galaxies are not at 4 billion light years away, which is already quite far. Those objects are much farther away when the universe was only 800 million years old. So this cluster of galaxies is in between. These 20 objects they studied are way, way, way out. And they are very small. So what they found is that, and the light normally you wouldn't be able to see, but because of the cluster, it gets magnified and James Webb Space Telescope sees that. Okay, all of that stuff is really cool already. But why are these objects crucial and why do they give us an answer regarding what knocked off those electrons from hydrogen fog? Well, because they detected in these small galaxies. So first of all, they are small in size, but they found out that there is a lot of star formation going on. It's called a starburst, meaning it's
Delish.
there is a lot of star formation going on. And the reason they know that is because of a particular line or detection of an atom, and that is of an oxygen atom. So there is a particular line that when a lot of stars are forming, you can knock out 2 electrons from an oxygen atom, and that usually gives you a sign, there's a lot of star formation going on. Now, this particular line, and the reason I'm going into this detail, again, don't worry about the details, but think about the type of things that astronomers have thought about to use it to answer questions. So this oxygen signature, you can think about it that way, from this galaxy, these galaxies that is coming in from a few 100 million years after the Big Bang, is in the visible light.
So you could see it with your own human eyes.
Well, if you had those gigantic human eyes, but you cannot because of the expansion of the universe, that visible light has been stretched into the infrared.
Quick pause. At some point in the very distant future, we will not be able to see any stars from Earth, if Earth exists, in visible light, because the light will have been stretched too far. The stars will be too far away. The light will no longer reach us. The end.
Well, I won't go that far, but in the very, very far future, there won't be anything left. But that's a whole other thing.
Anyway.
I think that will get us into a different territory. But this light that got stretched, so this was this particular oxygen atoms where 2 electrons are being stripped out. This happens when you are close to star-forming regions. And that light usually is in the visible. But because it has been stretched, it is in the infrared. Now, that particular light, is also been magnified through this cluster. And because it is in the infrared, it is perfectly suited to be detected by James Webb Space Telescope, which works in the infrared. So astronomers have discovered that these kind of galaxies, there are some analogs today as well, but the contributions to this kind of light is actually a lot less today. But they think that a billion years after the Big Bang or before, these small galaxies, because of their high star formation, were enough to reionize the universe or to knock out that electron from the hydrogen fog. So that is really cool, but that's not the best part. What I wanted to highlight was just think about the kind of things, somebody has to think about the fact that here is a cluster of galaxies. And you know what? You can actually look at that cluster to find out objects that are farther away. It can magnify light. And that light, by the way, would get stretched out. The signals that you have, a signature of star formation is going to stretch out in the infrared. So let's have a telescope that can detect that kind of light around the cluster, magnified from the cluster. I mean, I think it's just phenomenal how science progresses and how people have thought about these things and the beauty of it. I mean, I think there is some. First of all, you should also check out the images. Actually, those. I mean, if you search for Pandora's cluster and stars or galaxies, you are going to find this news item and those stories.
I accidentally signed up for Spotify's cluster. Pandora's cluster is older.
And also go to the James Webb Space Telescope website that actually has it highlighted. Those are beautiful images of that. And again, you're seeing these smudges, but those smudges are telling you so much about early universe. And just remember that these images are available for you to look at, for you to enjoy, for you to share, for you to use as a desktop
or for you to create an album surrounding or to use as your album art, because we as U.S. taxpayers paid for this. It is public domain and usable for whatever you want. It's part of what we've decided to do with some of our tax dollars to help benefit not only science, but aesthetics.
And you can use it. They're copyright free, and this is a key component that science should be shared. And I think U.S. Science has done a great job in terms of promoting that type of thing, and it should be continued. And this is the reason why we need some public support for NASA and NSF, because it is this type of science that comes out of it.
And now who knows what's going to happen with some of our favorite science programming now that the Corporation for Public Broadcasting is one Senate vote away from being defunded. What'll happen to NOVA?
Yeah, well, I mean, I think, and that is one of these issues that while we are talking about science and science funding, don't forget that how we talk about science and what medium we talk about science. So yeah, I mean, these are all things that are crucial, and that's why we should not lose sight. I mean, we could have just talked about the cluster of galaxies, but I think it's important of how we get to know about it, what's the beauty of it, and what to do with that. And I think what to do with that is something to know that it is for public benefit and it is for everyone. Let's keep on sharing this science.